Hello, everyone. Welcome to the Academy Day. In the next an hour, I'm going to cover how to move your databases to the Alibaba Cloud in order to run fully managed database as a service. Just a little bit about myself. My name is Haimo, and I am a staff product manager working with Alibaba Cloud. My current focus is really to drive product globalization strategy on the Alibaba Cloud for our databases, for our analytical products, and so on and so forth. Because as you can imagine, Alibaba Cloud was born in China, and a lot of these products were initially built and created to serve the Chinese customer demands. As we become more and more globalized cloud provider, we like to understand how other customers use cloud products in the US, in the European countries, in APAC, and so on and so forth. We take those insights back to refine our products, making sure that all the products are capable of serving all of our customers globally. So that is my focus, and very happy to give you guys some insights about what we have observed, what we have learned in the past couple of years, and then we can dive into understanding Alibaba Cloud databases a little more. Okay, talking to our customers, people have a lot of concerns. Well, even though they see the benefits, they still have a lot of concerns moving their databases to the cloud, and that includes the migration process. Is it easy? Is it a painless process? Am I going to stop my business applications? Is it going to be a native experience? Can I get some help from the professional team? And how do I manage? How do I operate in the cloud? So on and so forth. So we observed all those concerns, and I'd like to address the key ones in the next 45 minutes. So first of all, let's try to answer the why question first. You wanted to do more and spend less by migrating your databases to the cloud. If you look at the database usage internally by Alibaba, the chart represents that how the cloud databases are being used by a ton of business units under the Alibaba Group umbrella. If you look at these business units, so for example, this DingTalk is the next generation business collaboration tooling. It's used by a lot of business users, enterprises in China. It's the #1 business collaboration tool in China, right? Imagine how many databases we are looking at. Imagine how much data we are talking about. And then this Hema is a new retail concept offering a combination of offline and online shopping experience for our customers, right? That's a huge e-commerce or new retail platform. And then Cainiao Logistics on the other side of the house handles all kinds of logistics and shipping and that kind of stuff in China and outside of China. So that's, again, a huge business unit. So that only contributes to one of the 100, but each one of those is huge business unit, and we are looking at a huge amount of data. Now, for those business units, we have over 1 million databases just used by the internal Alibaba business units, and all those 1 million databases are actually managed by less than 50 database admins, right? And all those databases are now fully migrated to Alibaba Cloud, and all the databases are managed only by those many DBAs. So this is a quick chart to show the evolution path of databases over the years. Initially, when people started using database, people were mainly focused on the transactional data. How do I handle the transactional data? The core challenge was data accuracy. How do I make sure my transactional records are accurate and consistent in a high concurrency and high availability and high performance environment, right? That was the key challenge. And that's why essentially people came up with all the OLTP system, the transactional database with ACID, which guarantees that the right operation have to wait for data to actually hit your disk before returning success to the client. So that way, you guarantee the consistency, you guarantee the accuracy So when you read data from a database, the data you pull out is always what you have written to the database, to the disk, and you compromise some performance, right, in order to achieve that. And over the years, people start thinking about, unstructured data, right? So those are different from the transactional records. Think of logs, right? Think of those less important data points, but I still want to get some insights out of these unstructured data points. Now, when we talk about unstructured data points, oftentimes your application doesn't have to wait until the data is actually persisted. You have a relaxed consistency requirements, and then you have a better performance, right? That's for a different type of use cases for handling a document or a graph or log data and so on and so forth. And also over the time, people start thinking about real-time data, right? So what if, as an example, I have this Taobao.com, this e-commerce platform, and we serve over 1 million business users and sellers, individual sellers, and then we have 100 times or 1,000 times more buyers on the platform. For all the sellers, right, each one of the sellers, they run their store on Taobao.com, and they like to continuously issue queries to the backend to pull out some data points so that they can have business insights. So for example, they wanted to know the inventory management. Do I need to get more stuff in store, or is my inventory healthy? Do I maintain a healthy inventory? Do I understand my customers correctly? Am I satisfying my customers? Am I short in any of my SKUs? And stuff like that. So they keep sending queries to the backend. And imagine when you have over 1 million people sending queries to the backend, and everybody is expecting a response within seconds, if not milliseconds. So how do we handle that, right? That's why we innovated this whole new database called Analytical database or Analytic database. It was really designed for handling massive data processing and complex query, complex join to provide deep, intelligent insights to the end users. So now we have the transactional databases, we have the unstructured databases, which are the NoSQL databases, and then the OLAP databases for handling real-time data. The foundation, the cornerstone for all the 3 types of databases are a bunch of utility tools and services, right? Think of data transmission, data backup, data restore, data management, and security. And those fundamental services are not optional in order to bring enterprise readiness to all of our databases on the cloud. In the next session, I'm going to fully focus on the answering the how question, right? How do we develop the expressway for you as a customer to move to a fully managed database services on the Alibaba Cloud? The first common question we observed from a lot of customers is how to migrate with minimize the business downtime and ideally zero data loss. Our answer there is to leverage a product called Data Transmission Service, or DTS, which fully enables not only a full data or existing data migration, but also incremental data migration. So let's take a look at what do I mean by migration. Now, usually I have a backend server and I have an application pointing to a database. I might have this whole thing deployed on premises. Now I see the benefits of cloud databases. I want to move to the cloud, right? So once my databases are moved to the cloud, I can then switch my application. But as part of that migration process, how do I move my databases over? How do I move my schema objects over? How do I move not only the existing data, but incremental data over, right? So those are very good questions that we need to address. Let's take a look at the migration mechanism powered by DTS. If you look at this picture, this is your source database, and this is your target database on the Alibaba Cloud. And the best part is the source and target databases, they don't have to be the same database. You might be able to move data from a MySQL database to a PolarDB database, or maybe like a Postgres database, right? So you can choose between a list of sources and a list of targets. The first step is to do the schema migration, and this is done automatically. With DTS, it's able to automatically discover and detect the schema objects in the source and replicate and create those schema objects in the target, right? I'm going to create the same amount of tables with the same column definitions and then the same column mapping and stuff like that. The schema relationships and all that will be created in the destination database. After step number 1, we are going to start number 2, which is to migrate all the existing data from source to the target. And the step number 2 is usually taking longer time, depending on how much data you have in the source database. It could be like 5-minute process, it could be like a couple of hours, or even more than a day, depending on data volume. And the key question here is, well, I move, right? That's not, it's not practically, you cannot practically get it done in a matter of seconds. So what if my applications are still running? I still generate new data points while I try to migrate my existing data. So what happens to the incremental data? So that is the beauty of using DTS, right? As you can see from a timeline perspective, starting at this point, simultaneously, when DTS starts migrating the stored, the existing data, it also starts capturing the incremental data and replicate those incremental data to the target, to the destination database in the same time. So once you are done with migrating the existing data, it'll automatically start migrating the incremental data. At the end of this process, the two databases are truly in sync. Whenever you have a new piece of data written to database 1, it'll show up in database 2 in a matter of milliseconds. Now, at that point, as a business, you have the flexibility to keep both databases or to simply switch your application from the source to the target and then just get rid of the source and you're done with the migration process. As easy as that. So let's take a closer look at DTS architecture. I'm not going to dive into details for each of these components, but really I want to highlight a couple of points. First of all, we support a whole bunch of source databases as of today, 10 plus type of source DBs, and we still keep adding new sources down the road. And then in a very similar manner, we support a wide range of target databases. And in the migration process, right, when you do the full data migration, not only you can migrate your table, your schema objects, your data to the target, you also have the flexibility to plug in ETL scripts in the middle. You can run some SQL queries to modify your columns, right, to modify your table structure, whatever you like. You can plug in ETL scripts and make it happen as part of the migration process. And in the same time, when you migrate incremental data, those incremental data, before they hit the target, they will be temporarily stored in something called dstore, and this is effectively a broker service, right? Think of like a Kafka broker. They work in a very similar manner. Now, once you have those incremental data available in the dstore, what happens is you have this subscription SDK connected to your dstore data, meaning that for target databases that are not even supported by DTS already, maybe it's some database that you spin up on the VM yourself, and you want to pull data from source to that type of database, you can do it by subscribing to your data store, your dstore, right, via this subscription SDK. So for all those incremental data generated, you can push or pull to the your preferred target database, right? So this offers even more flexibility, right? So that you don't have to wait for a new type to be added to the roadmap, and you can get it done yourself. Now, the second concern that we observed a lot from the field, from our customers, is Now, how do I shift to a cloud native architecture design, right? Because as I move to the cloud, my architecture design might not be appropriate, right? So how do I get product recommendations, and how do I implement some of the cloud native best practices in the cloud, right? Do you offer service for me for that? So the answer is yes, right? The answer is yes. From a database perspective, we offer the database expert, right? So all these people, they are happy to help you with a very, very low price. So they can guide you through the entire process and then make you adopt a cloud native system design. So as an example, right, this customer, they had a like a design like that when they deployed their databases on premises. They have a web server, they have product, inventory, orders, and users for different processes as part of that web server backend, and those processes are writing data to a underlying MySQL database, right? So this is a e-commerce customer, and this was their on-prem database deployment and system design. Now, when our database architect team gets involved in helping this customer to migrate to the cloud, they identified a number of problems and they made recommendations. The first problem was scalability, right? So if you have 4 processes in the web server, now obviously the number of users and the number of orders is usually not the same magnitude. If you plan your resources around only the number of users, you might be running short in handling the orders, meaning that during peak time usage, maybe on double 11, when the same number of users submit like a lot more orders in a very short amount of time, your system might not be responding, right? Might stop responding during the peak time usage. So because of that, the first recommendation proposed by the database architect team was to actually adopt a microservice architecture to split your services, right? To split your processes, right? So instead of running all 4 processes in the same web server, they recommended using a containerized deployment. So you can have a bunch of containers for the product, services, inventory, orders, and users all separately. And those containers can run on separate resources. So you have scalability. The scalability is no longer depending on the, so essentially you can scale separately, right? You can scale users according to the number of users, and you can scale orders in a different way, right? And you have all that flexibility. And then the second problem, the next recommendation was to actually split your databases, because when you scale separately the processes, you might need a different database configuration. Maybe this database need to be much bigger than the database that stores the user information. So it's a vertical split between the databases. And then as a next step, it was also recommended to split your transactional workloads and your analytical workloads. Because if you want to run a BI software or something like that for visualization purposes, you don't want those requests to hit the transactional database directly, which might be having impact on the speed of processing the transactions. You want to add absolutely zero burden to the transactional databases. So once you move your analytical workloads to something like AnalyticDB, and all the BI tools, the visualization tools, the SQL queries can be pointed to ADB without affecting your transaction handling. And moving forward, another recommendation made by the database architect team was, now we are talking about separate databases. Why not adopting the PolarDB design in the cloud? It's a cloud native database which can scale based on your workloads. You have more orders, it's not a problem. You have more users, it's not a problem. You have less inventory services, you have less product service calls. That's all good. It's all okay. You don't have to make a make a prediction or a projection in terms of how many underlying resources I need for each of my databases, I just point all my services to the cloud native PolarDB, and it'll scale up and down and in and out according to my workload. Right, so you can fully take advantage of the ultimate elasticity in the cloud. So how do we make it happen? Right, this is a very brief architecture introduction for PolarDB. Now, without going into too much details, just want to illustrate how we make it happen. Essentially, you have multiple databases, and all these databases can be running in containers, not necessarily on the same physical server. So in this case, you might have 3 different physical servers. You have like these 3 databases, and then you have this one database that has a distributed nodes. You have 1 read and write, and you have 2 read-only nodes. So you have 6 databases in total, handling the different services, right? Remember, we talked about inventory and user and all that, and orders. And all the 6 databases can be pointed to the same underlying distributed storage, right? So this is a fully decoupled compute and storage architecture design. Now, if one of these databases has a exponentially grown workload, it doesn't matter. So all the data will be written to the distributed storage, and you don't have to worry about resource allocation for your storage. And then if you look at it in a different angle, PolarDB can be really broken down to 3 components. We have a Polar proxy layer. It's an intelligent proxy that does round robin or something like SLB load balancing. We have an embedded intelligent load balancing strategy. And then the second layer is a PolarDB SQL engine, which is 100% compatible with either MySQL or Postgres or Oracle, depending on your environment, right? Your database SQL syntax. And then we have the Polar Store, which is a optimized and distributed storage layer. Now, when you have a query that you want to issue, what happens is you run an application on the ECS that sends a request to the Polar proxy and will be routed to one of these databases. And then these databases, these kernels can write data directly to the Polar Store, or you can even have the flexibility to bypass the proxy layer. You can specify which specific database you want to leverage, and then you can send queries to that database directly and then write it down to Polar Store as well. So this illustrates how PolarDB works. Now, remember we talked about for like a really large enterprise, what if I don't want to move my code data to something like Hadoop? I want to keep more than 100 terabyte of data in my transactional database, which is absolutely not a common case, but still applies to certain cases. When that happens, this is going to be our next generation architecture design, right? So this is combining the ability to scale up and then the ability to scale out. So essentially, we can combine multiple kind of PolarDB horizontally. So all these databases, previously like maybe 3 databases interacting with a shared storage. Now, all these databases are able to interact with each of these shared storage, so you can effectively scale out, right? So this is a distributed architecture in conjunction with a scale up type of architecture. So this is going to be the next generation architecture design. Now let's shift the gear. We talked about the transactional databases. What about the analytical databases for handling real-time processing, the real-time data warehouse? This is ADB. Essentially, it provides a 100% compatibility to MySQL and Postgres as well with optimized performance, right? Low latency, it's really the key. Imagine in the e-commerce use case, the scenario we mentioned previously, you have a million sellers sending queries, very complex analytical queries to the backend, and everybody expects a millisecond to a second level response. So all those queries are handled by ADB, right? So it's high concurrency and high performance environment. we offer 99.99 high availability SLA, and the ADB is capable of handling PB scale data for both storage and analytical purposes. Let's dive in to look at the architecture for AnalyticDB in a little more details. Essentially, the front nodes are served as a master node to handle different kind of requests. And then we have an API layer. We have the modernized, the smart optimizer. I'm not going to dive into too much detail there because just for optimizer, we can spend a couple of hours to talk about the optimization strategy we implemented. But just wanted to quickly highlight, after the optimizer layer, once a SQL, the execution plan is generated and being passed to the SQL engine, we have a SQL engine called Xihe. This is a in-house developed next generation SQL engine, and in combination with my storage layer, right? So if you zoom into the SQL engine and storage, let's take a look at how they actually work. First of all, we have something called the coordinator, right? Coordinator nodes, and those are serving as the load balancer. When the SQL is being passed over to a coordinator, they're going to assign the calculation to either a compute worker or a data worker. So we have two kinds of worker nodes, compute and data worker. The difference is, well, first of all, it's according to a best practice, it's recommended to run either a compute worker or a data worker on one ECS. They better do not collocate on the same virtual machine in order to get the optimized performance, right? Because the compute worker and then the data worker, they prefer totally different hardware specs. Now, when you decide the hardware you like to use, you can allocate compute workers and data workers. So data worker, they, in addition to the computation the compute worker can handle, they also have a large amount of SSD disks, and those SSD disks are used for caching services. So imagine that the underlying storage, you have a distributed storage, but if you can cache some of the hot data in the SSD, this can speed up the query calculation a lot, right? So it depends on if you want to run a ton of complex queries and everybody expecting results back in a matter of milliseconds or seconds, you better configure enough SSD to cache those data. You can pull data from the underlying distributed storage, store those data temporarily on the SSD to speed up the SQL calculation. And then the compute worker on the other side, they pull data from data worker directly, and then they can do some compilation, some computations. And also, I like to mention that we leverage a so-called raft protocol. So this guarantees that for each piece of data written to the storage layer, we have 3 replications. And only when all 3 replications are persisted in the storage layer, we consider the operation a success, meaning that we actually sacrificed a little bit of performance in order to maintain and guarantee data consistency. We believe this is important for analytical use cases, right? So if you have maybe unstructured data and you want to handle unstructured data using a NoSQL database, then yes, you can have effectively relaxed the consistency requirement. But in OLAP use cases, it is something important that you better not to ignore. So we leverage raft protocol to guarantee data consistency. So the last problem we observed from a lot of users is how do I operate databases in a secure and easy manner, right? So that is why Data Management Service, or DMS, is born. It is the cornerstone that brings enterprise readiness to all kinds of databases, the transaction, the analytical, and the NoSQL databases. So the core functions of DMS, it covers 4 different dimensions. Basic function, you can actually issue a query from a DMS interface. You can explore the different schema objects, right, across the transactional and analytical databases. You can modify your data. You can kind of redesign your schema object. You can do all that with a well-designed user interface. And those are considered basic functions. And then more advantaged functions are security functions, stability functions, and research efficiency functions. So let's dive into each of these areas to take a look, right? I'm not going to cover all the possible functions because it just offers too many, but we can cover some of the keys to give you a sense of the capability of DMS and why we think this is important to operate databases in a secure and easy environment. So the first capability is full stack access control. Essentially, when you talk about access control, you have data access and you have control access. Data access meaning to send a SQL to the underlying database, and the SQL could be, select some data points, could be update my database table, could be truncate a table, could be drop a table and stuff like that. Now, when you talk about control level access, it is about the database instance. Maybe I like to create a new database instance. I like to reboot an existing database instance. So this is less about data manipulation, but more about manipulating your database instances. So two kinds of controls, two kinds of access, data access and control access. Now for both data access and control access, they are protected by multiple layers, by many different layers. Essentially, for data access, in order to access a database, you have to have the proper privilege, you have to have the account authorization, your IP needs to be on the white list, you have to be able to access the virtual network, right, the VPC and all that. If any of these layer returns negative signal, the access will be denied. So this is really truly a multi-layer protection, and it's the security level, it's actually higher than just the physical isolation. Although it's sort of like in the cloud, in the shared cloud environment, but because of people's knowledge, right, the security team's knowledge, we actually provide more security and more protections comparing to a on-prem deployment. And the same thing applies to the control access. We have multiple layers to protect your database from those kind of unauthorized access, right? So it's very secure. Another key feature offered by DMS is called a fine-grained centralized authorization management. What that means is you have many different types of users, maybe like a tester, a developer, an operator. And from admin user perspective, you want to assign different permissions to these different types of users. So you can choose a permission type. Maybe you want to define a permission for query, for update, or export different kind of queries. And then you can define the permission period for how many days this permission will be valid, for a year, for a month, for a week, right? You can configure that. You can also configure the permission target. Is it going to be applied on a schema object or a table or a particular column? So you can create a very flexible policy, right? Maybe one policy applies to operator plus developer for query, for update kind of query within 30 days, and that only applies to certain columns. And you can have a different policy that covers the entire table that is valid for a year for some of these other users. And you can do all that, the policy creation and the policy management, in a centralized place, right? That's why DMS offers a unified authorization management control system. And you can go there, you can grant, you can revoke access, you can define column sensitivity. Is it sensitive column or not sensitive column? You can do all that, and you can honor those policies, again, from a centralized place. Another functionality that DMS provides is called a log auditing. Basically, for every single function, every single activity issued by every type of user, doesn't matter if that's a SQL query, that is something to change your data, something to design your schema, to synchronize your schema, to export your data, to view your sensitive data and change your sensitive data. For every operation, every activity, we will have a log to record what happened. And then when auditor comes in, they can have a different way to play with those logs, right? They can run a multi-dimensional search. They can add a whole bunch of filters to look for specific people, specific database, and specific in conjunction with the specific functional modules, so on and so forth. So this makes the auditing process much, much easier. And then from enterprise perspective, if you use DMS, you no longer have to worry about auditing because all those functions are built into DMS from day one. And in addition to just the log auditing, we also provide the functionality for SQL auditing, right? So scenario-wise, think of maybe one day your database goes down all of a sudden, right? So what are the possible reasons for database going down? It all boils down to the lack of application level SQL reviews. From a developer standpoint, if I send a bad SQL manually, it usually wouldn't cause too much of a problem. But think of I, as a developer, I created an application that sends a bad SQL to my database, let's say, 10 times per minute. So that is going to create very, very serious problems over a longer period of time. So what DMS offers over here is called a SQL auditing functionality. So instead of running the SQLs directly and send SQLs directly to your database, you can send your SQL to the SQL execution module within DMS. So before the SQL queries are executed, DMS is responsible for scanning the SQL. Not only the SQL that you send manually, but also the SQL in your code, right? Your application code. So DMS is able to analyze all kinds of SQLs to identify those SQLs that might be causing stability issues. And then DMS can make a recommendation in terms of how to update the SQLs, or at least give you a warning that you better not to run these SQLs as is. You better kind of modify, refine your SQL so that your code does not impact the production stability. And that's very, very appreciated by a lot of our customers. So there's a lot more functions that DMS offers, but for the given the time constraint, I'm not able to cover all of these functionalities, but you are definitely welcome to look at the documentation to dive deeper into the management capabilities. And just a couple of success stories, right? This one new media company in China, they wanted to migrate their on-premise MySQL and Redis databases to the Alibaba Cloud. Their data volume was around 100 gigabyte existing data plus about 10 to 20 million rows per day. For that particular customer, DTS was able to help this customer migrate their databases seamlessly in a self-service manner, right? So they didn't have to pay for any consulting services. They just use ETL in a self-service manner, and the whole data migration process. When I say the whole process, I'm talking about the full table migration plus incremental data synchronization. The whole process was completed in 25 minutes. In 25 minutes, and after you migrate your data from on-prem deployment to a cloud deployment, it actually took just a couple of seconds for all their applications to switch to the cloud databases. So that was a big success for this customer. This other customer, they provide a online educational platform for students, right? And then they handle approximately 100,000 exams per day on average. So their systems needs to serve over 400,000 students during peak time usage. Now, when they reach out to the database team, their application was already developed, leveraging a microservice architecture using like containers and Kubernetes and all that. But still, their on-premises database constantly stopped responding during peak time usage, resulting in 1/3 of the students not able to access exams during the peak time usage. So they reached out to us, and then we provide a guided system revisit, system redesign to leverage the power of a cloud native database on Alibaba Cloud. So the customer was able to successfully migrate all their business functions to Alibaba Cloud, adopted ApsaraDB for PolarDB, which provides 100% MySQL compatibility, and they had zero change needed on the application side. Right? So they make they adopt the new architecture, and they didn't have to make any change at their application level, which was great for this one customer. As a result, they're now able to provide a very, very reliable service for all the students with a workload-based elasticity to handle their peak time usage with a steady performance. And as a result, their system maintenance cost was actually reduced by 95%. So a senior professional DBA was freed up from doing like the plumbing work every day, and this person is now fully focused on mission critical tasks instead. So that was a big change for the customer. And then another customer, this one particularly was a industry leading provider of operational SaaS services and interactive kind of advertising services in China. So they wanted to migrate their databases to Alibaba Cloud with requirements to secure not only the data storage, right, data at rest, but also data transmission, data in motion, as well as when you query your data, when you send a query and then pull data out, so that the data transmission between your clients and your servers. So basically, encryption and protection is needed everywhere. Now, for this one customer, quote unquote, from the customer, DMS provided a series of key functions, including but not limited to a professional operation interface, customizable security rules, comprehensive operational auditing, and so on. Right? So DMS not only brings enterprise readiness to the cloud-native databases, but also made these functions possible for self-deployed database instances. Right? And that makes a big difference for this one customer. All right, so enough said. Let me give you guys a very quick demo to demonstrate the seamless database migration experience. So let's take a look at a demo. Now, this is what I envision to demonstrate today. I have a MySQL database that is developed in-house and hosted on ECS. So from end user perspective, I just bought ECS from Alibaba Cloud and then run a MySQL database in Singapore region. So assuming that this is, it could be on another cloud, it could also be a on-prem database, but this is your source database. Now I want to migrate this source database to a target database of a different type, right? This is a PolarDB for MySQL. It's not exactly MySQL, it's a different kind of database. And in the meantime, I have an application continuously writing data to MySQL database. I want to migrate all the existing data in MySQL ECS to my PolarDB without losing a single data point that my application is writing into MySQL, right? So this write operation continues in the migration process, and then I'll just make sure at the end of the migration, every single records available in my SQL database is also available in my PolarDB that is available in another region. This is Indonesia, Jakarta region. So this is the whole kind of migration process. And then as I explained previously, this is going to involve 4 different processes behind the scenes. It's going to be pre-checking, schema migration, full data migration, and incremental data migration. Now let's take a look at the end user experience. All right, Jakarta, let's take a look at the ECS. If you remember what we talked about, it is going to be a MySQL database in Singapore and moving to a PolarDB in Jakarta. So let's go to check the instance in Singapore. Alrighty, so this is my Singapore region. I got a whole bunch of ECS instances, and I'm going to use specifically this test MySQL instance with the following IP address. So I quickly spin up this ECS instance using a pre-configured MySQL image. I'm not going to repeat that process. Is very, very intuitive and straightforward process. Just go to Alibaba Cloud, click ECS, and click Create a new instance, and you have the option to create from a pre-configured MySQL image. So I got this MySQL instance over here. And then I'm going to show you the PolarDB I have. The PolarDB here. Right? So the MySQL here in Singapore, this is my source database. And then this PolarDB is my target database. It's not in Singapore. I'm going to try to move to Indonesia in Jakarta. This is a way to demonstrate cross-region data migration, right? To simulate when you have a database on-prem or you have a database on another cloud provider platform, it'll be very similar process. So I'm going to use this guy over here. This is a instance that I created for testing purposes. So looks like we've got everything up and running. But before we do the migration, let's quickly log on to this database to make sure we drop all the existing schema so that when we start from scratch. So yeah, looks like we have a test schema here. Let me run this query first to drop the test schema, making sure that succeed. There's no longer a test schema. We start from scratch. There's nothing available in my PolarDB, in my endpoint. So now what I'm going to show you is the way that we demonstrate the migration. So I'm going to open a couple of terminals. Bear with me for the technical part, but I'll make sure this is as intuitive as possible. So what I do here is I'm going to documents, MySQL, documents programming, MySQL. All right, so over here, I've got 3 scripts. This one script here is to simulate. I have this application to keep sending data to MySQL database. And these 2 other scripts are accordingly pulling data out of the MySQL database and then pulling data out of the PolarDB database. So initially at this point, if I run, if I do sh migration demo query MySQL, you will be able to see data being pulled out of the MySQL database, right? This is simply a row count. It's a 294 rows available in MySQL, and this is sort of my source database. And then in a very similar manner, I'm gonna try to documents. I'm gonna try to MySQL. I'm gonna run another script to query my PolarDB database, right? So this one, right now, it returns an error, right? There's no such schema, there's no such database existing in my PolarDB, it's empty database, right? And then the third script I'm gonna run is, let's go to Documents, Programming, MySQL. I'm gonna run this migration script to insert data to MySQL database. Now, when I start running this script, right, you will be noticing a row count increased in MySQL, right? 294 going to 295, 296. So this is because I'm inserting data to MySQL database, right? Simulating that if you have an application that is running in the whole migration process. And here the target doesn't have any data points, right? It's pretty straightforward. Now, what I like to demonstrate is I am gonna go to my DTS. Now, in this case, I am moving data from Singapore, MySQL, to a Indonesia, Jakarta, PolarDB. So I'm gonna go to Jakarta and then create a so-called migration task within DTS. So let's give it a name. This is demo migration from, from I don't know, 1 to 2. And instance type. This is my source database. I'm gonna say I want to use a user-created database with a public IP address that looks reasonable. That's available in Singapore. It's a MySQL database. And the IP address, let's go to the ECS to copy and paste this IP address. This is on my ECS instance. All right. And then the port number, database account, and password. You just get those passwords and username when you create the MySQL database. Quickly test the connectivity, successful. And I'm gonna configure my destination database. I'm gonna go for a PolarDB, and that is configured in Indonesia, Jakarta region, and I'm gonna just choose a PolarDB that is available. So I'm gonna go for this migration test database, right? And then test account, password, and I'm going to quickly test the connectivity, making sure that DTS is able to connect to this PolarDB successfully. So it's taking some time because some network connectivity issue, but now it's passed. So successfully connected to both the source and target database. So I'm okay to proceed. All right, over here, you see this is the schema that is being automatically detected by DTS. We have this test schema available in my SQL database. I'm gonna do both the schema migration, the full data migration, as well as the incremental data migration, right? Meaning that when I do the migration, the data that's being inserted by this application to my SQL database will be synced up to my PolarDB. So let's just move everything over, and I'm gonna do a pre-check. This is done by the evaluation module, right? To do the pre-checking to make sure everything looks good, everything there's no drawback, there's no surprise, there's no sticker shock in the migration process. And you can see there's a bunch of things that's being checked by DTS. Everything looks good. I'm gonna go over here. This is different pricing option. I'm just gonna go for the default option, the large channel. Data transmission, agree to the terms. Quickly start this process. So at this point, I have created this task, this migration task, right? Demo migration from 1 to 2. And I can, this is a scheduler. I can, start a task or multiple tasks at once, depending on my business needs. So let's say the status is migrating. I believe this is automatically started after the pre-checking process. So let's minimize this window and take a look at what's happening here. All right, not yet. Status migrating. All right. Let me kind of stop it. All right, let's just keep an eye on these scripts and see what's happening here. Sending data to MySQL. There's no data in PolarDB yet. And then this is the application. Keep writing data to MySQL. All right. Let's put it this way. All right, so now the schema migration is 100% down, meaning that when you pull data from PolarDB, you can already see the row count being 0, right? So the schema objects are migrated. And then now, when you query from PolarDB, it's a 345, 355, that's the full data migration. And that's like one big chunk, 355 rows. right? This tells me that we are still doing the full data migration. We have all those rows, but data hasn't been successfully inserted yet. The moment when I start seeing 356 and 357, that tells me the data, the incremental data has been ingested to PolarDB, right? So as you can see, there's data, increasing in my SQL database from my application. This is data generated during the migration process, and those incremental data has not been captured in my target database. Let's give it some time. All right, so now you can see this is caught up, right? 366 and then 367, 368, right? That means going from here to here, those 11 rows that were generated in the migration process, they have been successfully captured in my PolarDB endpoint, and now my target and my my source databases are in sync, right? Running this DTI's mission. So this is how easy that you can migrate your database from source to target on Alibaba Cloud. All right, so that was a quick demo, and thank you everyone for watching my session at this Academy Day online conference. I hope you had a good time, enjoyed the session, and learned something that could be useful about Alibaba Cloud and specifically about databases. If you have any questions about the whole kind of migration experience, anything about databases, definitely feel free to click the ask a question box on your right-hand side. We'd like to invite you to also claim your Alibaba Cloud product coupons by clicking on the promotion banner. Remember that these coupons are only valid in March. So after you claim these coupons, you better use them by the end of March. So if you are ready, don't forget to click the button below to start a very, very short test for the database topic. So after you successfully going through this test, you can then apply for a recognition of attendancy certificate. So that'll be, you can put it up, and then this is how much you learned from this session. And you also have the opportunity to sign up for ACA offline examination for free, right? So that's only free and only available today. And yeah, thank you so much for coming to the session. It is my pleasure sharing my insights, my knowledge, my experience with you, and I definitely look forward to talk to you guys in the future. Thank you very much.